Actually, you better shift on this side. You'll be able to see the screen like this. Because it is difficult for you to do this. Yeah. So, okay. So got it right. One way is you can write directly in the cloud. Start coding. Actually, don't need to do any installation. But not a good have. I mean, you can do that when you don't have access. But otherwise, it's better to have a local response. Okay. Now, okay, I was talking about NumPy.
Do you have a Wi-Fi connection that you use?
Yes, yes, yes. You can use this guy. Zclabs training will be there. Connect to this. Zclabs training. Password will be this. Oh, can't see that, huh? Can you see this? Zero. Zero, that is zero. Yeah.
Where we can install this? Jupyter. How? Where we go to install this?
Just to download next.
Okay, just
Yes.
any version of Jupyter.
3.6. I mean, Jupyter is the latest version. Python version should be 3.6. Yeah, I was talking about NumPy before you guys when we had a brief introduction about data science and all that. We can talk about that later. Okay, so after that we started with NumPy. Okay, NumPy, as I was mentioning, is meant for fast mathematical computation. First of all, okay. Secondly, it is it's a homogeneous data structure. That means you'll be storing same type of data. Like if you, unlike your list where you have different type of information, right? Here you will have same type of information. Like you're talking about numbers, everything should be numbers. When you're talking about string, everything should be string, right? And apart from that, it has a lot of inbuilt utilities. Okay, inbuilt utilities means like in list, it doesn't. You have only sum, max, min, very limited utilities, right? Here you have functions which can do, which can actually find standard deviation. Here you have function which can find your, variance, linear algebra, matrix multiplication. So you have all those things just bundled up together. Now, the NumPy was extensively used by NASA and ISRO. All this satellite company organization where they deal with a lot of mathematics computation. They used to use NumPy even before machine learning was using it. Right, so that is the thumb rule here. It's for doing maths. That's it. Okay. Okay, so that is what. So we'll now first see how do we create NumPy. Okay, so there are various ways. These notes are available to you after the session for lifetime. I mean, this repository. Okay, so you needn't take efforts of writing all the stuff.
So everyone please write your name and WhatsApp number
so that we can create a group for that.
And it will be helpful for attendance.
Okay, so yeah, all the things are here in the GitHub, so you can connect to this guy. NumPy, concatenation creation and all that. This is the stuff. Okay, so as far as creation is concerned, so you have various ways to create it. Okay, first is you can create a NumPy data structure from Python list. Okay, you have a regular Python list, you would convert that into NumPy. Okay, precisely because NumPy, if you have to do some computation on the list, you could prefer to do that on the NumPy data structure because it will be faster. I'm not talking about 2x faster, I'm talking about 100x faster.
If in this different types, if different types of elements are there, means different types of
right, then it won't convert. It won't convert. See, the thumb rule, one rule that you can remember, when you are confused, program is also confused. Right? Had this question, I mean, suppose I asked you this question, that suppose there is a list which consists of both number and strings both. Will you be able to convert into NumPy? You say no. How can I write? So when the rule is, if you are confused, this is confused. So you just try this 3-4 times, you will always be correct. Okay. So first, what you're doing here, this is how you're importing NumPy. Import NumPy as NP. Okay, as you can see, you don't have to do any installation before you use it. Okay, you can actually write this code in your try Jupyter as well. You can do this. Yeah, we did that. Import NumPy as NP. So what is happening because of this? Is it visible from the last?
Yeah.
Okay. So what is happening? You are importing NumPy as a library, and you are aliasing that as NP.
This is in Jupyter.
This is the Jupyter. This is the free repository for you. Try.jupyter.org. Right? You can. This is a cloud URL. You can use it. Of course, what you should do is you should install Anaconda. This is what I was talking about before. This is Anaconda. You will download Anaconda. Okay. So let me know if you face any problem. We can arrange some help for that. Okay. So now here, what we intend to do? We intend to create a NumPy array from list. Right. So can you see a list here? 2, 3, 4, 5. Right. This is a list. You're passing this as a NumPy array. np.array. Okay. You're passing this list. And what is it returning? It is returning a NumPy array. So we will execute this. Shift enter to execute anything. Okay. Shift enter. Yeah. Okay. So now you want to see the content. Just place the value and shift enter. You'll see the value inside. So it created a NumPy array which contains the same element as list. It is not pointing a reference to list. It is creating a NumPy array itself. NumPy array, as I mentioned earlier, it is like C array internally. Okay, it is internally like C array. Okay, let's see more things. You want to give, so now the data type is integer over here, right? Right, you want to pass here float. Right, you want to pass here float. Right, so you mention here, this is a list that you are passing and you D type.
Here we are not print a.
You don't need to. In Jupyter notebook also, you don't. If you want to print something, just write the variable shift enter.
Okay, it's because of the
It's
feature.
not
It's
a
a NumPy feature.
It's not a number. Okay. So if you do D type is equal to NP float. Float, there are various type of float. Float 16, float 32. I think you very well understand what will be float 16 and 32, right? Number of storage it uses, right? So yeah. And if you want to see the data type of it, A.B type is precisely giving you the type information. Okay, and then you print A. Then when you print A, 2.3.4.4, 5, 1. So what is it giving you? It's giving you the values but in float format. Right? That is precisely because you gave you the float information. Clear, right? So far, what are you doing here? Of course, it's having said that it's never the case that you will use NumPy only for storing numbers. You can also use NumPy for storing strings, and that is what you see here. Okay, so just see it carefully because I'll ask a question now. You see, you are creating an NumPy array with a list hello world friends. Okay, then you do B type. Okay, you do a B type. When you see this U7, let me not explain what is happening. Can you guess what is happening? What is this 7? What is this? At least what is this 7?
Maximum elements.
Right. Got it, right? So here, see, as I mentioned earlier, it is C array. In C, how do you create an array for storing longer? So you will create a static array, right? Of course, you can create using malloc. You can create some content, but basically it's a static content. So that is what here it is, which is a static information. So now reading this, it understands, okay, the maximum size it requires to hold any word is 7. So it will create a 3 rows of 7 sides, 7 columns. Right? So that is why it is U7. Clear?
U stands for
Unicode string. Yeah.
If we are writing friends, so just you can add one more s. It's friend double s.
Then it will add 8. Just and then I didn't tell it before, but it is the data this NumPy, right? NumPy is mutable. Any idea what is mutable?
We can change the
update, we can modify.
Right. So you can modify the size. So if you do B0, you can override the value that is present in this case. So if you do B0 this, what will be the output if I try to dump B?
word friends. We update
With the entire thing, or how is it?
first hello will be replaced
By
new string ABC.
the entire string or a part of it?
I think only the 7 letters.
Absolutely. Good. You'll replace only by, because your memory is already fixed. Right? It's not that you'll use this example when you're writing. Okay, you will eventually never use now strings mostly in NumPy. But few of the things I do it so that we understand how it is working only for academic interest.
The memory is fixed because of the third location, but still
Because when you are creating this array, the line number 8, when it executes, it actually allocates all the memory that is required for this execution to happen. Okay. All right, so it's pretty much done with the memory allocation part. You're just manipulating the contents. That does not mean you will be reissuing them.
no matter how long the string is.
Only store to 7, the first 7 characters.
can we modify the length? Can we modify the length or
No, once then you have to rewrite the B. Right. As you see here, only the first 7 characters get stored. Fine. Okay. Now let's see this line, and I would want everybody to execute this also, just to see how the execution looks like. Okay. You can use try Jupyter. If you're connected to internet over here, you can use try Jupyter and execute it. Do this NP zeros, and you can see double braces here. So remember, throughout machine learning, many places you need to pass size. Right? Size of array, size of data structure, size of this. Right? You'll in here and in deep learning courses, you will see that you're passing the size information. So when you are passing the size information, right? Okay, what you're doing there, you are precisely. When you're passing the size information, you will be passing size in tuple format. Right? You'll be passing size in tuple format. Got it, right? So that is why when you say 4,4, it means a matrix of 4,4 you're getting allocating here. Got it, right? 4,4. So what is in NP zeros 4, without me saying anything, tell me what it will do.
We create a matrix of
4,4. Absolutely. Right? So believe your intuition, because the amount of information that you will be coming across is too huge. You have to start trusting your intuition and try those things first. Okay, so the aptitude that you have learned over last 20-25 years, or depending on your age is, right, it will come handy. So keep those things on, right? Because what happens when you're writing code in Office, each time we stop using our intuition thing, because right? This will be there, this will not be there, those things But here there will be a lot of new learning that is happening. So keep your intuition bit on. Okay, so let's write this piece of code here. NP zeros 4, just execute it and see what is happening. You can use tryjupyter.org. Okay, in case you don't have anything installed, you can do this. Something like NP, first do this.
zero dot?
Yeah, so let me ask you, what does 0 dot?
Looks decimal.
Absolutely. Then decimal means float, right? So that means the default data type is float. Got it, right? Okay, let's proceed further. Everybody executed. Right. Yeah, so if you are trying try Jupyter screen, so you might in the right hand side you'll see new or something like that. Huh? So if you are in this page, okay, you'll see this new. Click on new. You can see all the variations. Click on Python 3. Yeah. So they write import NumPy as NP to import the library. Or what is the password? Is it password issue or what?
I don't know. Network security key mismatch.
Password issue. So did you write the same? Welcome with W capital in place of O replaced by 0 at the rate 1744. Fine. Huh?
While creating an default text every number as 464.
Yeah, default type is 460. Okay, let's see more. You see here, here you gave 4, 4, right? It means a matrix. What will happen if you give 4, 4, 4? 3D, right? A cube actually, 4-dimensional cube, right? So if you dump the data, it will be like this, right? Isn't it? Right? Okay, 4 times 4 plus 4 matrix. That's it. Okay, then you have 0 like. Okay, what is this 0 like? So what are you trying to do here? NP 0 like A. Okay, NP 0 like A. So here A we have created earlier, right? When you do 0 like, what it is trying to do? It is trying to copy the data structure size and replace it all by zeros. What is A earlier here? A was this data, right? Let me dump it. A is this data. It is one row of 6 elements, isn't it? Then when you do NP zeros like A, it is trying to copy the same size here, right? With all values replaced by 0.
It will be assigned to a new variable or
It will return it. So if you want to assign to new variable, you'll do B is equal to. Right? 0 like means it will copy the data structure size and replace the contents with all zeros. Right? It is used. It comes very handy if you're trying to make a copy of the existing infrastructure and get
we can store anything in.
Right.
Can I store that in another variable?
B. If you execute, it will store it here. Okay, so similarly, you have ones, right? All values getting initialized to 1. Then you have ones like all values getting initialized to, whatever is the content of it, it will make a copy of it, and all the values will be replaced by 1. Fine, right? Same stuff. Then you have something like full, right? If you do NP full 6,699, what will it do? It will create a 6x6 matrix. All the 99 values, all the values replaced by 99. Of course, you can write a string also here. Right, you can see here the utility that I was talking about. It already provides a lot of APIs to make things faster for you. I mean, quickly you can write some implementation. That's the thing.
You put random number.
Yes, you can do random number also. We'll see. Then you have full like. Full like means it will copy the data structure type and replace the contents with 10 here. So understood, right? Zeros and ones are like nothing but specific implementation of full. Okay, let's see further. Okay, then in Python you come across range, right? You come across range. So here you have arrange, a range. So this is the starting point, this is the ending point, and this is the separator. Starts with 10, ends at 20 with 20 exclusive, and it is separated by 2 value. Right? Okay, so then you have this guy, NP arrange 10, 15 minus 1. What will you do? 10, 15 to 10, or reducing 1. Okay, coming more to random. Okay, so what is this random number here? And any idea what is random number? And why do you think is it useful?
To generate a random number given in between the range.
Yeah, random number is very useful in machine learning or level 5. This is one code that we'll see we are using very often. Random number. That's because if you want machine learning to give you robust behavior, you must randomize things to see how it is behaving. Right? Okay, so that's what. So we'll use random number generation a lot throughout machine learning to do a lot of this learning stuffs and all that, so that we can randomize the thing and data, then send it to the machine learning application, then see how it is behaving. This sort of applications we'll see and we'll understand what happens. But first, to generate random numbers, what you can do is if you do np random.rand, all the random number utilities are inside np random. Np random.rand, and you are doing passing 10, it is generating 10 numbers between 0 and 1. Right? Then you do, this is the number data that is generated here, right? Okay, reshape, I'll show you, start using it. I'll show a few things around it. But if you do d.reshape 4,4, what you're trying to, whatever data it has generated earlier, right? Okay, it will actually, so how much data is it generated earlier? 10, right? Yeah, they should not execute because, so maybe I can do 16. Yeah, so you can see we are generating here 16 data, right? If you do reshape 4,4, what you're trying to do, you're converting the entire D data into a 4x4 matrix. That is what reshape. We'll see a few more things around reshape. But reshape, you can see in the bracket 4,4 I'm writing. That is what we're doing. We're converting the data structure into 4x4 matrix.
Each block is in NumPy. In Jupyter, just bring the last statement.
Right.
It can also be uneven matrix like 5,4 or 6,8, something like that.
Yeah, as long as the product is matching to 16, 8,2 also it can be, but it has to match it, right? Otherwise, how will it do? It could get confused. Okay, then similarly you have ran n. N is a normal distribution. What is a normal distribution? Normal distribution means bell curve. Data is more towards the central tendency. You learn all these things in the math session. Okay, but if you're what you're doing here, a normal distribution of data 4,4. That means that mean of the data is 0, and it is how far it is from mean. Right? So it is generating a normal. If I plot the data, the curve will be like this. Normal distribution curve. The curve will be like this. You're plotting the data. Got it, right? Okay. Then you have this np random.randint. Okay, so what is this random.randint doing? It is actually generating you, yeah, integers, whole integers between 5 and 10, whereas 10 is exclusive. Remember, in all of these cases, the last value that you'll see, right, it will be exclusive of that. Data that is generated here will be between 5 and 9. And what is the size of the data? 3 cross 3. Right? Okay, so that is why you'll see data in this format here. Fine, right? What is randint, rand, and rand? 3 APIs. Then you have shuffle sort of an utility. When you do np random shuffle d, it will shuffle the contents of d, and it is like it will modify d itself. Right? It will modify d itself. Fine so far? Okay, then you have seed. Okay, what is this seed? Seed is something, some external parameter which controls how your which controls how your random numbers are generated. Got it, right?
And it is a defined method. Right? It's a defined method how the random it's always constant.
Yeah, no. There are a lot of ways. How many of you had heard of this, like Gaussian, Poisson, right? Many of these guys were there in creating the content which has tortured us in school and colleges mostly, right? Right? We had this subject CBNST. I don't know it's there now or not, but when I was doing graduation, it was there. Computer-based numerical, I still don't know the form. So there it was more of this different mathematics equation, Fourier equation, and all that, right? So that is why different mathematician has devised new ways to learn. So you can, of course, if you do this. Okay, if you do this MP. Okay, you see, a lot of binomial, chi-square, Gillet, all different sort of mathematician here. Normal, okay, Poisson, Pareto, Rayleigh. Oh, tab. For this command completion, right? You can press tab. You automatically complete it for you. Understood, right? You have different techniques, so different is the way. When you do this, NP random seed 67, every suppose if I don't do this, every time my output will be same or different? 967, remember, right? It's changing. If I use same seed every time, the output will be fixed. 876. 876. That is what
blocking the output of the random.
Right.
Tagging it to number 67.
Huh?
Tagging that output to number 67.
67, yeah. So every time you execute the same code in your machine, you will get this. Just execute it. These two code, right? Execute it, you should see the same output. Exactly.
So if you will change the size, then
it will be different, of course, right?
but the order will be the same. It's the number.
8, 7, 7, 7, 6.
No, again, yeah, it's not necessarily actually.
I know the series uses many.
Do you mean this? Right, so this part is the same now. Okay, but there is no such rule for that. It's just happening in this case maybe, but there is nothing which ensures this.
What is that? 67. 67.
67 is a number, and it can give any number, but your output will be tightly coupled with that number every time you give this.
What exactly does it?
So what it does is when you're generating random numbers, right, you're using the 67 as one of the parameters which decides the random number which is generated. Okay, so every time you have the same seed value, you'll generate same values.
Kind of label we are assigning to the set of numbers, random numbers.
Right.
But initially I thought it's like more machine specific, but looks like
Let's say you execute, you'll get the same output.
I saw the same. So it's like it's when we assign
Yes, algorithm is specific.
input to the random number.
Okay, now comes the part of accessing. Okay, so here you have np random.c. Okay, so what you're doing here, and here you're generating numbers from 2 to 20, isn't it? Right? 2 to 20, and the size of it is 5 cross 5. Right? So, and what is happening here, it is generating a data for you 5 cross 5 matrix, and the values are ranging from 2 to 20. Okay, so so it has created a matrix for you like this. If you want to access elements, you can access it the same way you access list. Right, access list. So that is why you can see data 2, 1. Right, it is accessing second row first element like 19. Right.
Second to first element is 18.
Second row 2, 1. First element is 19. Oh, this is the value 10 actually. This is row number 0. This is row number 1. This is row number 2. Okay. Got it, right? Okay, so accessing. Okay, so here you see here data and one column, right? This is very similar to Python syntax, isn't it? So what would it possibly do? First row onwards, all the rows till end. Then you have colon 2, right? Colon 2 means till second row or first row? Right? 0 and 1 row. Right? Row number 0, row number 1. If you want to access columns, okay, when you do colon, comma, that means all the rows. 1, 3. Right?
1, 2, 3 is first and second column, 3 excluded.
3 excluded. First and second column, 3 excluded. Absolutely. Got it, right? That's why it is out. Fine.
But
Now,
if it's index from 0, shouldn't it be starting?
Hmm?
If it's the index is starting from 0,
Hmm.
the first element will be data 0 or data 1?
0. So when you write colon 1, it will print only one column. Make sense? Right. So for 1 colon 3 means column 1 and column 2 only it will be printed, nothing much. So now you can a small exercise for solving. Okay, you create a matrix like this using this code. Okay, after that, using using this code. After that, get me the middle three elements like this. Understood? This values. Your output should be 19, 10, 11, 10, 6, 18, 13, 13, 3.
Once again,
Your output should be this. First create a matrix like this, then write a slicing, get an output like this. Everybody finished so far? Nice. 1 to 4, 1 to 4, right? Okay, I think this is all here. We got the result, right? Code if we have to do it. Data. Right, 1 4 1 column 4 1 column. Fine. Some few stuffs. Okay. You guys comfortable so far? Now let's take it further. Okay, now we'll talk about shapes and sizes. Okay, it is an important aspect because internally a lot of mathematics computation happen, like matrix multiplication and all that. Okay, so many times you might have to take care of the shape and sizes explicitly, and more so when you do deep learning and all that. So this is where we build the foundation now. When you do this, data is the 5x5 matrix that we have created earlier, right? If you print here shape, remember this is not a function here. That's the reason I'm not putting braces. It is a attribute here, right? When you do data.shape, okay, when you do data.shape, you're trying to print 5x5 here, the shape of it. When you do size, it basically tells you how many elements are there. Okay, then you have data.ending. Ending basically tells you how many dimensions are there, number of dimensions, right? It's very intuitive with the words that happens here. Now we'll do some reshaping. Remember this tracing: shape, size, and ending. Okay, let's proceed further. We have this reshaping functions now. You have this array which is like one dimensional array of 6 elements, isn't it? Okay, if you do a shape, it will print 6 comma, right? Endim, you'll print 1, right? Now what we are trying to do here, we are trying to reshape to 2 comma 3, right? We are reshaping it to 2 comma 3. Okay, so what do you do? Yeah, 2 columns, right? 2 columns of 3 elements. 2 rows, sorry. 2 rows of 3 elements. Got it, right? Remember, since it is 6 elements, the product has to be 6. Fine, reshape. So again, you have stored the data here. Again, you can do b.reshape 6 so that it again converts back to the same stuff. You can do a lot of interesting stuff with this. And b.ending 2 and all that. Pretty much you are expecting this. Now, fine, right? What is reshape? Okay, a few things you need to take care here. Now you can of course convert it into 3 cross 2 as well. Right, 3 cross 2 as well. Okay, it will be this. Again this. Okay, so pretty much as long as the multiplication values is same, like if it is 6, you will do 3 cross 2, 2 cross 3. If it is 12, you will do 3 cross 4, 6 cross 2, and all those possibilities. As long as it is same, it is all good. Now comes important aspect. Suppose you have a data like this, and this is something that we'll use very often. This is one-dimensional data. Many times you need to convert this one-dimensional data into multi-dimensional data, at least two-dimensional data. See that the reason is, whenever you are doing trainings of models, I'm talking a little bit forward. Okay, it might not be so clear now, but when you are doing some machine learning sort of an activity, you'd want data to be in rows format, right? I mean, you have this much, right? When you are, what is machine learning? You are passing some data to this, a lot of data. For example, when you see, housing.com predicting the price of your house, you need to pass a lot of house prices to it, isn't it? House information to it. Okay, this all information will be passing as rows, right? Just understand that this fact that whenever you are doing machine learning or later on other things, you need to pass a lot of data together. Not like if you have to do some analysis based on student record, you will have to first 20 students record, right? Each record will be one row of data. Make sense? Right? Like you can imagine your Excel sheet, each record is one row of data. Right? So many times if the data will be available to you in one column, one row of one information, but you realize that this is each information is separate. Like in this case here, it is 6 elements, but you need to convert this. This is a one-dimensional array, right? But you need to convert this into 6 rows of one element, so that each data is treated separately. Understood, right? What I'm trying to say here. And here, what is the shape of a 6 comma? One dimension. What you need to convert is 6 comma 1, 6 rows of one column. For that, okay, I'll show the best. Okay, for that, what you can do is, okay, you can, it is 6, so you can do a dot shape, it will give 6 comma, right? So a dot shape 0. Okay, what is it doing? It is returning you 6, isn't it? See this.
Yes.
Will this work? What is the will this work? So 6 into 1 is 1, right? Say 6 into say 1 is 6, right? So what is happening? It is converting your data into 6 rows of one element, the way you see it below here, right? But I find this very ugly code. And if somebody is writing this, you should understand he's a very new to data science. A decent, so experienced person will never write this sort of code. You'll write this sort of code. So what you're doing here is you're converting that a into -1, 1. What is happening? What is the second column is 1. That means number of columns is 1. Number of rows -1 means let it be interpreted from the data. Okay, that means what is the possible values of rows here? 6. Right. Similarly, you see -1, 2. Why it is -1? Number of rows, let it be interpreted. Number of columns is 2. So what is the number of rows it will interpret?
3.
Absolutely.
If it's the odd number, if you put 0 or something.
See, it will only work if you maths work. Otherwise, it will throw error. Right. Same rule. Some rule. Okay.
So -1 actually interpreted from the input.
Input, right? It will be interpreting this value from the data itself. Power, yeah, it's okay. See, other ways to do is, you want to add new dimensions. What we have learned here, how to add one more dimension, right? So of course you can keep adding more dimension by adding more shapes. Like if you add one dimension and give it 1, 1 value, you don't need to add more data to that, right? Suppose you have a data with two elements, right? If you convert it into reshape into 2, 1, 1, 1, it will work. Suppose you have a data like this. Okay, A, will it work? Will it work? No. Who else is saying no?
It might be 0. So
Okay. Anybody else? How many of you say yes? How many of you say no? And how many of you are neutral? So who is yes? It will work.
There are 6 elements. Is it pretty multi-dimensional array? Single element each.
Multi-dimensional?
Array with single element and something.
How about others? So what happened?
Bit of nesting.
Yeah. So what they did here, see, for adding one dimension, you don't have to add data. Remember that line. How much data you need? 1 into 1 into 1, and no matter how much you do, this is adding one dimension on it. But it's not really needing more data there, right? And finally, it is this. Right? And say if you change this guy to 2, so it's 2 into it will be 3.
And every time it takes the 1D array as an input.
Hmm?
Can we give a two-dimensional array as an input?
Ah, of course. Doesn't matter.
Reshape.
Yeah. The number size of element should be same.
Okay.
Apart from that, it should not matter. Fine. Okay, there you have. Okay. You have A, and what you're doing here, you're adding more dimension. NP new access means you're adding more dimension. Whatever data you have, it is, see, A was previous one row data, adding one dimension. Data was two-dimensional data, it is adding one more dimension. Beyond it, beyond one point of time, it will not be easy to imagine it, as you understand, right? But just see how it is happening actually. Data was two-dimensional stuff.
Can you explain 89?
89.
Row was one, A was one dimensional.
When you do np.new access, right, it will add one more dimension to the data. Similar to reshape. Okay, similar to reshape. Just that you keep adding np new access, it will keep adding. Yeah, more data.
Looking the same.
It's adding a list.
Right, so just a Python teaser for you guys. So we have data was how much? 25 by 5 cross 5. We reshape it 25, that means it is converting to one dimensional array. Data.reshape star data.shape comma one shape. What is this? A Python teaser for what is star in Python? So how is variable arguments coming in picture here? Why is the data output like this? Somebody explain me that. Okay, I'll give you 5 minutes time for this. Okay. Winner gets a gift. Gift is surprise. Okay. So tell me, how did the output come like this? Okay. I mean, you can treat this as a break as well. Break count. I mean, always the breaks will be in shape. There will be some question and there will be some break. Okay. So people who may want to make use of estimates over there. Understood the question? So you have the answer also here. This is the question. You just have to tell me how you are getting from this to this.
I'm trying to do this to see any answer.
So anybody, any answers? Some messages though.
Like variable arguments. Actually, dot shape is written in a tuple, so we want each element from that tuple. That's
Ah,
why
right. So when you put a star, you actually unenvelope the data. Got it, right? You get rid of the tuple part of it, just get the contents of it. And so what replaces over here is 5,5.
Yeah.
Okay.
Even if we give the list string in any
Data structure which is your list or tuple, right? If you pass star to that, it will return you the contents of it. Okay. So
One question.
oh, sorry. I thought.
You have written it data.reshape 25,
Mm.
right? Means after that when I'm executing it means data.shape. After that also it is showing 5,5, right?
Because it is returning you the changed data format. Okay.
not updating the actual.
Huh?
It is not modifying the actual.
It's not
data.
modifying the actual data.
Modifying.
Right. Just returning you the updated contents. Okay, and most of the data functions will be like that only. It's returning you the contents. So if you want to store that, use it in some variable. If you are not storing it anywhere, it will be just dumping the information.
But for this, it has changed, right? Before it was 5,5. Now when we have reshaped it, it's like 5,5,1. For this, it is changed, but for that, it was not changed.
Which it is changed?
For this one, data.reshape, and then whatever we are giving, then dot shape. So this time shape has changed.
Right.
But for the above one, shape has not changed.
Even this, it is not changed. It is returning you. Here I am just see. It is returning you the changed object. and you are applying the shape function on it. So it is actually not changing. That's temporary variable. It is. Okay. Then many times you just want to get rid of the dimension. That means whatever is the data structure, you basically want to convert it into one dimensional stuff. So there is where you'll see Ravel. Right? Ravel function. What it does is it converts your data was 5 plus 5 matrix, right? So what you're doing here, NP Ravel, it is converting into one dimensional of 5 elements. Right. Okay, then you have concatenation. Okay, understood so far? Dimension, getting more dimension, adding more dimension, and blah blah, all this sort of stuffs. Then you have concatenation. Concatenation means you are combining information, combining NumPy. See, you have two NumPy arrays, X and Y here. Okay, when you do concatenate and in the list you pass X, Y, X, you are trying to create a new array which combines all these operations. Okay.
Why we are doing 2 times X?
You can give any times of X. You just want to combine the data twice. Okay. A few important checkpoint here. Axis. In NumPy, you'll come across this word axis. Axis means you have horizontal axis and vertical axis. What is horizontal? One. How do you write one? I'll tell you. It will remember it. One means you write one like this, right? You write one like this, right? Okay. So what is axis number one? Axis number one is counterintuitive. This is axis number one. You write one like this, but the axis number one is like this. This is axis one, or this is known as horizontal axis. So one is horizontal axis. The way to remember is this is counterintuitive. Okay. Then you have axis 0. Okay. Axis 0 is of course vertical. Understood? Right? Just remember it this way. So why this axis? You'll use this axis very often actually.
One is always horizontal. Zero is vertical.
Right. Okay, so you see this data here.
Yeah. So if we talking about 2-dimensional, then we can say 0 and 1. Is there any way of talking multi-dimensional?
Multi-dimensional, you might give more information, dimensional information.
So it comes 0, 1, 2, 3.
Yeah, but frankly speaking, I mean, generally this multi-dimensional stuff, you won't be dealing directly with it. Okay, so what will happen internally, if you write something internally, it will create multi-dimension, do the computation returned to you. Mostly information that you will be dealing with will max 2 dimension. Got it, right? It will internally use multiple dimension to do a lot of things, but when it comes to you dealing with it, you will be dealing with mostly axis 0 and axis 1. Beyond that, anyway, so see, when you do NP concatenating into data comma data, okay, what it is doing a vertical concatenation. What is vertical axis? Axis 0. See, it is putting on top of another. Understood, right? And when you do axis 1, it is placing it horizontally. Huh? Yeah. So when you don't mention anything in concatenation, so data is your matrix, right? 5 from 5. So when you don't mention here anything, it is doing a vertical concatenation by default. That is, default is axis 0. Got it, right? Default is axis 0. Then you have this guy, axis 1. Axis 1 means horizontal, right? So that is why you're connecting like this. And remember, whenever you're doing this vertical concatenation or horizontal concatenation, if you're doing vertical concatenation, the size of the base should be same, so that they can sit on top of one another. Again, intuitive, right? If it is smaller or bigger, of course, it will not fit. Similarly, when you're doing horizontal concatenation, the number of rows should be same. Right? Understood axis 0 and axis 1. Okay. Okay, now you see more things. See, okay, then you have this. This is one array D1, and this is another array. If you do NP concatenate D1 comma D2, what will happen? This is a two different data types, right?
Yeah.
It will try to upcast it like numbers. It will try to upcast into strings, and because one data structure can only have one type of data, right? Okay.
It
Now,
doesn't do the other way around, like when we have a list
Hmm.
with numbers and characters, if we try to convert list into NumPy array, it will not upcast, it will get error.
right. List into array. It will list into. Come again.
If we have a list which has 1, comma 2, comma 3, then A, B, C.
Oh, yeah.
If we convert into NumPy, it
Hmm.
gets error. It doesn't upcast.
These doesn't upcast actually. Okay. So the next thing is append. Appends mean adding a data at the end, right? So if you, this is the data and this is one array. So when you do append, you can see here it is flattening it out and it is adding the contents at the end like this. Right? Append. It's not this is not something you use very often.
Yeah, but why does it flatten it?
This is how the reason why it behaves like this is, you have the contents here. Right? If you don't want to flatten, you can pass this as a list of lists, right? So it understands the dimension information. When you're passing as one dimension and it is two dimension, it really doesn't know what to do. Should it add here? Should it add here? What you should do? So it'll flatten it out. Again, just these are just append and all. You won't be using very often. You'll be using pandas for doing this operation. Okay, again, whatever you have seen, of course, you can use H stack and V stack. H stack means horizontal stacking. V stack means vertical stacking, right? So if you're doing horizontal stacking, number of rows should be same. If you do vertical stacking, the number of columns should be same.
Same thing can be done by changing axis.
Right. Is it clear? Okay. Then similarly, you have splitting. The same important thing to understand is splitting is you have horizontal splitting and vertical splitting. Actually, how you should read each split is splitting the horizontal axis. What is horizontal axis? Like this. If you split the horizontal axis, how do you split it? This is exactly. This is the horizontal axis, right?
So you split it like this.
Right, split it like this actually. Vertically. Okay. So this. Okay. So this is your horizontal axis. And if you have to split like this, isn't it? So this is your data, 5 cross 5. If you are passing this information to, it is dividing the data from the second part, right? So it will see 2 and 5 cross 2 and 5 cross 3.
Why should I given that as a list? Maybe is it like 11 as a list, or is that the number 2 we are given?
This one.
So I just split data comma 2.
Data comma, yeah, because you might pass here multiple places where you want to split, right? Depending on where you are slotting the data, okay, you will return that many number of variables. It will one will be 0 and 1, second will be 2, and third will be 3 onwards all. It will return 3 variables. Got it, right? It will return A, comma B, comma C. Got it, right? A. B. C. right? Similarly, you have vertical axis. Vertical axis means you have vertical thing split it
Split
horizontally. So you basically, you mentioned 2 here, you will see dividing the data into 2 parts. This guy and this guy. Understood, everybody? Right? Dealing with this is a concatenation, creation, concatenation, and splitting around it. Okay, let's do a little more stuffs. Okay, so we have dealt with shapes and sizes and all those. So now what we'll see is, okay, we'll see a few more things around it, huh? So this is what you're doing. Import NumPy is empty here, right? Then what you're doing, you are creating a NumPy array, right? Each one A contains 0 to 9999 and the B contains 0 to 9999. Last number is exclusive. Okay, so when you do percentage time it A plus B, what is happening over here? Percentage time it is a Jupyter notebook utility. What it will do is it will tell how much time does it take to do the following operation. Okay, so when you do A plus B, it tells you that it takes around 18.6 microsecond and 781 nanoseconds. Right, 781 nanoseconds and A plus B. This is your okay. So this is what it is telling you if you do plus operation. Okay, understood, right? How to use this utility. So we will now compare what happens if you use this utility and if you don't use this utility. I mean this utility in the sense. See what you have here. What is this range? This is a Python utility, right? It will return a list of 0 to 9099. If you use sum of this is a Python again, not a NumPy operation here.
It's a Python operation.
It is executing and it will tell you how much time did it take. It took 553 microseconds. I will do the same thing. This sum here, right? This is sum of the entire stuff. Okay, so I'll do the same thing. Anyway you have created. So I'll do this percentage time it np dot the cumulative sum is sum of all the elements in it, similar to whatever you have, and you pass it will tell you the time that is required here. Can you see that the time difference is around 10 times faster, isn't it? Right, on a very structured data, 10 times faster. And if you add more unstructured part with the complex data, it will see much more case. But and the data is also not much, just 10,000. Right, understood why NumPy? Because the operations are pretty fast here. Okay, so when you're using NumPy data structure, refrain from using Python utilities because that's not optimized for this case. Right? Okay, you have a lot of utilities like NP sum data. This data is a 5 cross 5, not 5 cross 5. It's a little bigger than that. Data is this guy, right? NP random in 1 to 10 and size 10 cross 10 matrix, right? So when you and if you print data, it looks like this. So when you do NP sum data, comma x1, what you're trying to do here is what is x1? X1 is horizontal axis, right? So NP sum means it is trying to do sum of each element along the horizontal axis, right? Along the horizontal axis. Clear, is it?
Along the horizontal axis, you mean like each row or
Along the horizontal is each row.
each row?
Like if you see sum of this element is actually 41.
4 plus 2 plus 5.
49 for that matter.
49, that is what I was saying.
Yeah, they didn't execute that, right? Similarly, if you are calculating mean of it, you see a lot of these utilities are pre-built for you. NP mean along that axis, NP standard deviation, NP cos, right? Okay, it can do a lot of matrix multiplication, max. Then utility is max. You understood, right? The maximum element along that axis. If you do axis 0, then it will give you very useful operation, right? Where when you have a lot of data, you have to find some, along this operations, what is the highest data, this operation, what is the highest data it uses. Then there are a lot of utilities around arg, right? Like what is this NP arg max means? It will find the argument, it will find the index of the maximum data. Because so what will, if I execute this, okay, you'll see sixth value is highest along that axis. 1, 2, 3, 4, 5, 6. Yes, indeed. The first highest value, the highest value is 6. There is nobody which is greater than this, right? Make sense?
It doesn't count 0.
That's value 0, 1, 2, 3, 4, 5, 6.
Okay.
Okay, arg max. Similarly, arg min, right? And similarly, arg sort. What is arg sort? Arg sort will give you index values of the in the sorted order. Okay, this value is in the second in command. This is the highest.
Lowest.
This is the sorted order actually.
But it doesn't.
Oh, that's because I didn't execute it. Right. Right. So there you see.
Yeah.
Right. So you can see this is the smallest value. This is the second smallest value, and 1, 2, 3, 4, 5. It is actually sorting that entire.
It is giving the indexes actually.
Yeah, indexes. Arg means indexes.
Yeah.
Okay, arg means. So let's see here. This is the smallest value, right? So it should be 1, 0, right? And you can see here, this is all the same values. This is that it will be putting one after next 10 on indexes. Understood? So arg sort will give you sorted indexes. Yeah. Okay, so these are the mathematical utility that you can do on the data. So you can, okay, so note down this URL. This is the place where you will contain all the nodes and everything. Okay, you should note, or what you can do is you can fork from here. You can fork it. Okay, if you have a GitHub account, so that it starts showing. So whatever updates happen, you will be notified for that. Okay, I recommend you doing that. If you not, you can download it. Okay. Yes, all the files contents.
So for today, which will be going to.
So today we have gone through 2 files. One is this and other is this, right?
So you will give the links to this?
I'll save it, I'll upload it. Now itself. right? So you can just search for NumPy and you'll find this. Just now, this is the one, right? Then this one. Ways toward the one, you should give it a shot. And all the assignments tomorrow I'll show you. Okay, you can click on wiki and you'll find assignment. No, that is NumPy problems. You'll find this lot of questions here. Try solving them. Okay, then and not these are for data stages. Pandas assignments are there. Okay, these are the not those. Okay, then tomorrow I'll show you another link. So you do data science assignments. So these are your assignments, more further assignments. Okay, I'll show the links. Today, what you try practicing it out, whatever we have discussed. You can write your names, name and phone number for WhatsApp group, so that everybody is notified, the updates and all that. Right, got a sense to it? Anything that you are not able to follow so far? Okay.
Here we most of the time we created the random matrix and but in there we will be reading the data.
Yeah, you'll be reading most data from files, some other servers and all that. So for that you'll be using pandas actually. Okay, so we should study after this. This is like the core element of it. Can you understand? A lot of things will be internally implemented using NumPy.
We can read repeating.
Yeah. Right. So I would urge for a after the class, I would encourage to you have Saturday Sunday you have the whole week, 4 5 days. So it's not that don't wait for Friday. Right. Okay. Every day I have dedicated exam. Okay, I'll study on Monday, Wednesday. I'll tell you something that has worked for other people. You keep it dedicated because most of you are working and it will be difficult to get time dedicated for this. So keep a time slot fixed. Okay, no matter what happens, I will study at this time. Okay, and switch off your phone. The challenge is, when you're working. Okay, because there is always a lot of distraction. Office is there, other parameters take care. If your family life, then again one more parameter gets added over there. But everything is inevitable. Just have the dedicated slot and let everybody know around you. Okay, this is the dedicated slot where you are running this. Okay, because initially it will be simple, and as it goes further, the curve will get steeper actually. Yes. Okay. This is your WhatsApp number, right? Is this the same Tarun shared with us? Because
yeah, that's the one, Avantak.
Okay.
That's the WhatsApp. That's the WhatsApp number.
Okay.
Thank you.
Okay, let's catch up tomorrow. The last conversation. Yeah, just please wait a couple of minutes. Okay, anybody felt sleepy? I was checking everybody. I didn't find anybody sleepy. Because that is the feedback how I get it actually. So Saturday afternoon, you guys will be fill up with some probably good lunch and all that, right? So afternoon class, I have to keep some extra check. It's
move to the morning time.
Huh? Sorry. Yeah, we'll move it. Their morning class going on, which will be ending in a couple of weeks. Huh? Everybody stays nearby, or how is it? Walking distance? Nearby? Oh, just really far, right?
Very far.
Oh, very far. I thought it's near Hibba, no? Nowadays, especially, it is not yet finished, right?
I take to go to England.
Oh. Tomorrow we'll learn broadcasting, which is if somebody asks one question in NumPy, it is usually broadcasting. I mean, somebody means interviewer. Okay, because it's not that you will be using it, and you always know in interviews people ask question that is never so useful in real life, right? It is more to understand. Typically, somebody is trying to judge your comprehension skills, right? So generally, broadcasting is a little not so intuitive concept. It's easy otherwise. Is that, I mean, that's why initially the question list of questions that HR have it, or the first level of interaction that it will have. Same thing. Okay, it will have this broadcasting concept. Then it will have that string I showed, right? String thing. Because if you don't do it deep, you will never see it. Right, so these are the standard questions that generally first. I mean, if somebody asks things in NumPy, these are the questions. Anything else you guys want to ask?
Do you suggest like we should go through some of the mathematics by ourselves?
You can do. I mean, for that there is a good website, onlinestatbook.com. It's a good website to come through. But having said that, sometime your maths class will also happen. Ashish will take the maths class, 4 hours of maths class, where we'll be discussing things from here itself. But if you think you have time at your disposal, you can actually go through them. Okay. Or you can try getting hold of class 12 statistics. That is a good starter. Class 12 statistics. NCRT. Okay, I didn't knew that. I saw a couple of months back my cousin book. So yeah, so I found that pretty useful. So that is a good starter. Okay, Amitesh is here, so I will ask a few things.
So how's the class? Good. So we'll continue for this for maybe next week, and then we'll shift to a morning batch. Till next week it will be the same.
Not the model will become